Hi, welcome to my latest video. Today I'm going to be changing my glow plugs. This job has been put off and put off and put off for months and months and months. Last winter my car refused to start when it was below about -3 degrees C. It just wouldn't start. I had to use the easy start, and I even used brake cleaner at one point and did a video of that. Okay, so here's a quick thumbnail of the video from last winter. It was -6 or something or other, and yeah, the car just was an absolute pain to start. So I remember saying in one of my previous videos, I'll do my glow plugs in the summer when it's nice and warm and dry, long sunny evenings, plenty of time, plenty of daylight to strip this all down and get to the glow plugs, because it is a major job. Have I done it? No. It's now a week before Christmas. It is actually dry and fairly sunny today, but it is mid-December. It is cold and it will be dark by about 4 o'clock. Okay, so it's now 10 AM. I've allocated the whole day for this. I've read up. I know what I've got to do. It's about 6 hours work, so I can just about get that done before it gets dark. Hopefully, we'll see how we go. And change these glow plugs. Now, as part of this job, I've got to remove the inlet manifold. And to remove the inlet manifold, I've got to take the fuel filter off. Okay, so I'm going to renew the fuel filter, and then I'm actually going to fit a different inlet manifold without the swirl flaps. Okay, so I won't go into what those swirl flaps are now. There's going to be a separate video talking about what they are and why they're a bad idea, and also show you how to remove them from a manifold that does have swirl flaps fitted. All right, so I'm going to be just swapping mine for a swirl flap free manifold, but when this one's off the car, I'll sort of strip it down and show you how to remove the swirl flaps from your manifold if you don't want to fit a later one, you just want to refit yours back to the car. Okay, so that'll all be in a separate video. It's one day's work. I'm going to sort of film the entire lot and then sort of chop it all up into 3 separate videos. So fuel filter kind of off at the beginning, and then eventually refitted last of all. That will be one video. The manifold then going off or coming off and then going back on. That will be another video. Okay, and in between the removal and refit of the inlet manifold, I get to the glow plugs. Okay, so here are my new glow plugs here. Bought these ages ago. And I'll be changing those. So this video is the glow plug bit in the middle of the day. Okay, so I'm going to sort of jump ahead in a minute. The next footage you'll see, all of this hopefully will be kind of stripped down and removed, and I'll be getting to the glow plugs. Now, if you are doing your glow plugs, you will need to remove the fuel filter and the inlet manifold. Okay, so go back and watch the previous videos. There may not be the immediately previous video, it depends if I sort of squeeze something else in between, but there will be videos that I have uploaded recently for fuel filter and inlet manifold. Okay, and you need to do that as part of the glow plug change. Okay, so it's a big job. This is one reason why I've been sort of putting it off, and here we are in the middle of winter, and I actually need to do it now. It's a bit like a sort of dentist's appointment. You put it off and you put it off, and eventually you end up with a bad tooth, and you've got to go ahead and do it. Okay, so it is not too cold today, but we've had sort of -5 recently, and I'm sure in January and February it will be below 0 at some point. Okay, so there'll be another big freeze at some point. Well, sod's law says if I do this now, it'll probably be the warmest January on record or something silly, but I need to do this. I need to do this for peace of mind, that if I wake up on a frosty morning, I know my car's going to start, because I might not even be at home. I might be away on business with my day job or visiting friends or relatives. I don't want to be taking bits of the throttle body apart to squirt easy start and things like that in, sort of doing, away from home. It's just going to be really awkward. Okay, so got to get this done, and as well as sort of changing the glow plugs, I'll show a little bit about the different types of glow plug. Okay, because there are 2 different types. Super important you fit the right ones. There are 12 volts, sometimes labeled 11 volts, and there's also 5 volts. You get the wrong ones, it's just not going to work. Okay, So I will look at the part numbers, I'll look at the different ones, I'll look at the wiring, relays, control modules, and also talk a bit about sort of when these glow plugs actually get turned on, okay, because they're sort of automatic, okay, there's no switch or anything, they get put on if the computer thinks they're needed, really. So something that's very difficult to test unless the weather is freezing cold, really. So you can obviously sort of remove glow plugs and test them and test these and that, but to actually test the starting of the car with the glow plugs, it's got to be a freezing cold, frosty morning, really. So I'm sure I won't have to wait that long for that to happen. So what I may do, depending on when I drop this and when the next cold morning is, I might be able to put a bit of footage at the end of the video, sort of actually showing it starting, like below zero. We'll see what the weather does. Maybe that could be a sort of little bonus feature video sort of in the future at some point. Right, I need to get the camcorder on the tripod, and I need to sort of start stripping this down and work fairly quickly, really, because the day is just going to disappear, and then I know what will happen. It will be pitch black and cold, and I'll be out here bent over the engine still fiddling away with it, okay. And it's Sunday today, and tomorrow's Monday, and I need the car tomorrow, okay, so there's no wasting time. This is one of those jobs where I've got to just roll my sleeves up and get on with it. So what I've done, as well as buying these glow plugs here, is I've bought myself a little torque wrench, okay. So I bought a huge, great 400 Newton meter torque wrench when I did my wheel bearing, because the hub nut is something ridiculous, like 350 Newton meters or something, and that torque wrench is absolutely completely unsuitable for doing glow plugs, okay, because these are 15 Newton meters. I think I'll have to just double check. Is it even written on there? No, it's not. But yeah, I think it's 15 Newton meters, which is not a lot, really. So this torque wrench is a little tiny Magnuson one, B&Q, 37 quid, I think, but it's 5 to 25 Newton meters. Nice little diddy one. And it's got a little 1/4 inch drive, okay, so perfect for doing glow plugs. As well as sort of using a torque wrench to fit them, it's a good idea to use a torque wrench when you remove them, because the worst thing that can happen with glow plugs is they snap off. Okay, they're only an M8 thread, and let's just open up one of these and just have a little look at what it looks like. Yeah, you see it's very thin, very delicate. Okay, so that goes down into the engine, the end, and this part here can get sort of carbon and soot and possibly even rust and things like that sort of on it, and the whole thing just seizes, jams into the cylinder head, I'm guessing it goes into, but it can get stuck, and then you go to undo it and it breaks off, and then you've got a real problem. You've got a real problem then, because you're going to have to sort of drill out the glow plugs somehow. So what I intend to do, because this car is now 14 years old, it's 180,000 miles, more than that, 185,000 now I think, these glow plugs may snap. Okay, so I'm going to use the torque wrench to undo them, and I've heard if you sort of tighten them a little bit and then loosen them, that improves your chances of being able to actually unscrew them. You have to very carefully work it, but the important thing is that in either direction you don't go over the shear torque, which is about 20 Newton meters apparently, according to the web, which is not much over the 15 that they need to be actually fitted properly. So it's all very, very careful and delicate, no big kind of bars undoing things madly. That it'll just snap them off, and then, I mean, if a glow plug snaps off, I don't even know if you can drive the car. I'm not sure. I guess it depends where it snaps, really. But yeah, worst case, the remains of the glow plug then sort of disintegrate and fall into the engine or something terrible. So it's a high risk job, this, but it is necessary. I've got to do it. I just need to do it very carefully, and I absolutely must not shear these off, okay? Okay, well, we must not shear off the ones that are on the car. These don't shear. These are brand new. I'll put these in with a bit of copper grease on the thread, but the old ones very likely to shear off. So before I start removing anything, I just want to talk about the different types of glow plug, and also talk about the connectivity and the wiring and how they're controlled. Okay, so most important thing, really important, there are two types of glow plug. Okay, so there are the 12 volt type, which are actually confusingly labeled as 11 volts. Okay, and there are 5 volt glow plugs. Okay, as a very rough guide, the 5 volt ones are fitted to the later models. So, okay, so mine's a pre-facelift grille. Okay, so this sits lower than the headlight. If your grille, the bottom of your grille is in line with the headlight, okay, that's the facelift grille. The later ones from sort of mid 2010 onwards. Okay, to be really sure, you need to check your chassis number. Okay, so the chassis number is up in the little window thing in the bottom of the windscreen. Okay, just below the wiper. Okay, so I'm going to put up at the bottom of the screen now the range of chassis numbers that use the older 12 volt or 11 volt glow plugs. Okay, the later models that use the 5 volt glow plugs, the chassis number for those is at the bottom of the screen now. Okay, I will also put up the part numbers. Okay, so here is the part number for the 12 volt glow plug, and here is the part number for the later 5 volt glow plug. If you're still unsure as to which type your car uses, then you need to have a look down in here. If you've got the 5 volt ones, there'll be a control module sort of sitting down here somewhere. Okay, here's a picture of the control module so you see what it looks like. I'll also put up the part number for that control module, because you never know, it might be your control module that's faulty rather than your glow plugs. What I'm going to do now is I'm just going to try and move a few things out of the way here. I've got my Webasto air filter, which needs to be fitted properly, air horns on their special bracket that clips in there, and eventually I can get to the fuse box here. Okay, the older models with the 12 volt glow plug, I'm not going to call them 11 volts. I know they're labelled as 11 volts and people are going to comment and go, oh, they're actually 11 volts, not 12. I'm going to call them 12 volt, okay, because it's driven by a relay with 12 volts. Okay, so if you've got the 12 volt one, you will have a relay. Now let's just double check which one it is. Here it is, look, R4, okay, and it's got a curly wire thing. Okay, that's the sort of universal symbol for glow plugs apparently. Okay, so R4. Now where is R4? It's this one down here. Okay, this one here. Okay, so you've got R3, that's air conditioning, that's something to do with the engine, that's God knows what, SM, what's SM? Don't know, but it's this one down here. Let's just pull that out. If your glow plug light on your dash is lighting up, but you don't believe your glow plugs are working because your car's not starting, then check the relay if you've got a relay, check the control module if you've got a control module. The relay's a lot easier to check. You just get someone to start the car and you'll hear it kind of click. What you can do if you want to is swap it with maybe R6, which is the heated windscreen one, okay, which is this one. Okay, which one is it now? This is confusing. This is very confusing because we've got R5, R6, okay, it's this middle one here is the heated windscreen, alright, so it's the same relay, so you could swap that one with R4, and if the glow plugs still don't work, then it's not the relay, okay. If they suddenly start working, then you know you might have a faulty relay, okay. So this relay here, you can tell by the size of the pins on that, it's a pretty chunky one. Let's just see if I can see It is a 70 amp relay. Alright, 70 amp relay. That's what you'll have if you've got the earlier 12 volt glow plugs, alright? It's really important to fit the right ones, because if you fit 5 volts to an earlier model, 5 volt glow plugs on an older pre-facelift model, then they're just going to burn out straight away. All that work for nothing. The first time they come on, they burn out. If you fit the 12 volt ones on a later car, then they're just not really going to get warm. They're not going to glow properly. Okay, they're just going to be useless. So it's super important that you get the right ones. Now be really careful if you buy them online. eBay and Amazon and even some motor factors, they label them as the wrong voltage or the wrong part number, or quite often you'll see something like this. I'll put a screenshot up now which says Freelander 2 glow plugs 2006 to 2014, the whole range. Well, how can that be so when half of them are 5 volt? You see what I'm saying here? It's really easy to buy the wrong ones. When I bought my glow plugs, the first pack of 4 that I bought the wrong ones. They're 5 volt. I looked at them, I thought 5 volt, oh, that's a bit strange, they're being driven by a relay. So measured, the voltage is 12 volt, I need 12 volt glow plugs. So these ones here, these are Bosch ones. Now, I have no idea what out of this lot is a part number, okay. I'll try and work out a Bosch part number and put it up at the bottom of the screen now. Okay, but these are the Bosch Duratherm, something like that. They're Duratherm, it says there, actually, not therm. You'd think therm for a glow plug, but no, it's term. And they also, just to be really sure, it is written on the glow plug. Okay, now let me see if I can zoom that so you can see it. Okay, just going to position that, right, and then if I zoom that in, it says there 11 volts France. Okay, so 11 volts. Check yours just to make sure you've got the right ones, because you never know, you might have been sent, you know, the wrong ones in the right box, but the wrong glow plugs, or mislabeled or sold wrongly on eBay as the wrong type. So do check what's written on the actual glow plugs themselves. To test the relay driven 12 volt glow plugs is a lot easier. Okay, so I've lost my relay now. Where have I put it? Oh dear. Oh, there it is. Okay, so what you can do is get a meter and stick it down in here. Okay, so you can test for sort of 12 volts being put across these two terminals here. Okay, that will energize the relay, so you can check that the computer is actually turning the relay on, or trying to turn it on. Don't forget that the glow plugs only come on if the outside temperature, or I think it's actually done on the temperature of the coolant actually, so the temperature sensor in the coolant, engine temperature sensor, is reading about below, as a rough guide, below 0. Okay, some people say it's +3, +5, -3, -5. I've seen my glow plug light come on the dashboard. Here's a quick photo now of the light, so you know what it looks like. Okay, it's a sort of curly wire, same as this sort of symbol here, and it's a yellow light, okay, or yellow or amber light on the dash. It'll come on briefly, and it'll only come on if the computer thinks it needs the glow plugs, and that's usually sub-0 Celsius. Okay, I don't know what that is in Fahrenheit. I'll put it at the bottom of the screen now for you Americans, and I don't know if Canada uses Fahrenheit, probably, but anyone else in the world that uses Fahrenheit instead of Celsius, I'll stick that up at the bottom of the screen. There is a temperature at which the glow plugs start to be used. All right, so it's no good trying to test for glow plug energization in the summer. They just won't be powered up. You can test the continuity though. So these glow plugs, are very low resistance. They're about 1 ohm. Okay, now the resistance will actually increase as they get hot. That's just sort of what happens to certain materials, certain metals, and that the resistance goes up as they get hot. But when they're cold, about 1 ohm. All right. So to start with, forgetting the fact that the resistance changes as they get hot, to start with, you put 12 volts on 1 ohm is 12 amps. Okay, and there's 4 of them. It's 48 amps. 48 amps to start with, and that may drop as they get hot, but to start with, it will be 48 amps. That's a lot of current to be pulling out of your battery when you're about to start your car on a very cold morning. This is why there should be a delay. Now, not all Freelander 2s do it. Mine doesn't seem to do it. Okay, the older ones, you hop in, you put the key in, you press the button, and it starts cranking before the glow plugs have had a chance to get warm. Now, on older Land Rovers, older diesel cars, you had to sit there kind of with the ignition on, wait for that glow plug light to go off, and then you started. Modern diesels, you don't seem to sort of have to do that. They just sort of start straight away, well, or not, as the case may be. But if you put the ignition on, so put your foot on the, or don't put your foot on the brake or the clutch, brake for automatic, clutch for manual, and just press the start button, then the glow plugs will warm up, but the engine will not start, and that gives everything a chance to not only heat up, but also for the current to then turn off again before you start to crank the car. Okay, because that starter motor needs all the current it can get. Okay, so that's the sort of two-step process, as they call it. I put up a video years ago showing that. Caused a lot of discussion. Some people said, yes, you know, this really works. Others said, that's actually how you're supposed to start it. Others said, no, this is rubbish, you're not meant to do that. Others sort of said, it won't help. Okay, so I find it helps. Others, a lot of other people have said it helps. Give it a go. It might help you start your car, okay, on those cold mornings. But the thing to remember is if your glow plugs are faulty, or your control module's faulty, or your relay's faulty, then you could wait 10 minutes and it won't make any difference. The glow plugs are not going to get hot, okay? So if your glow plugs are working, it might be worth doing that sort of two-step kind of delayed start. Some people find it helps, okay? Just going back to the 5-volt glow plugs, why did Land Rover switch to 5-volt glow plugs? Okay, later models, the 5-volt glow plugs have this control module that's a sort of pulse width modulated control module. Okay, so it allows the computer to sort of modulate, control the heat of the glow plugs. Okay, so the voltage is actually delivered in a sort of a square wave, and the on time and off time can be varied. It's called pulse width modulation, so that it can go full power or a lower power. I think what it does is it goes full power and then it sort of drops back to a partial power whilst the car tries to actually start. Also, 5 volts, if you think about it, is you're always going to be able to get 5 volts to them. Okay, so if you're cranking your engine and your battery voltage is dropping down sort of 11, 10 volts, you still get 5 volts at your glow plugs. So they can still glow, if necessary, with full heat. 12-volt ones, as soon as your battery voltage starts to drop, the voltage available at the glow plugs is also going to drop. Okay, so 5-volt is better. Okay, it's a much better way to do it, but there's added complexity there. The control module is it's not as simple as something like a relay where you can just get a meter and test it. Okay, so if you think your control module's faulty, you're probably better off doing like a diagnostics with a code reader or something like that. So what I'm going to do now on my relay driven 12-volt glow plugged car is just do a continuity test. Okay, so you can't do this really Well, you could actually do it on the later 5-volt ones, but yeah, you'll have to kind of get into the wiring somewhere. Okay, you can't just sort of stick it into the relay socket. If you can find the output from the control module and test from that down to the engine block, then that will at least show you if that wiring and the glow plugs are working. So what I'm going to do now is I'm just going to put my meter on, put it on musical mode. Okay, so it sort of beeps. So okay, so probably actually better. I don't know what resistance it has to be below to make a beep actually, so I'll tell you what, let's put it on the 200 ohm. Okay, so when that's shorted out we should get 0. Obviously there's a tiny bit of resistance in the leads. And what I'm going to do, try to do this with one hand. Now the relay output, if we look at this here, it says that pin 5, I can't read this, pin 5, okay, so it's this pin here, I'll point with this, it's this pin here, which is the one that's sort of 90 degrees to the other 3. Okay, so that one is the one nearest the engine, it's this one here. Okay, let's zoom in a bit so you can see that, it's a bit dark down in there. Yeah, so it's this one. Try and point this one here, this one, okay, 90 degrees to the other 3. So that one is the output, and that on the older relay driven one, it's literally just a wire that goes down and is daisy chained across all 4 glow plugs. Okay, so we should be getting about 1/4 of an ohm, because 4 1 ohm resistors in parallel gives you 1/4 of an ohm. All right, if one or more of them are blown but at least one is working, we should still get 1 ohm or slightly less. If we're getting a high resistance, then all 4 are blown. Okay, so what I'm going to do is, with the meter on the resistance check level, let's just put this over here. I'm going to stick this down in here into that one there, and then I'm going to touch this onto the engine block, okay, which is where the other end of the glow plugs are. So let's just put it onto here somewhere. Okay, right, I'm putting that on there, and there's just nothing. Okay, it's high resistance. I mean, let's just whack that range right up here, 200 kilo ohms. Oh, there we go. Oh, hang on. So that's kilo ohms. No, no, it's gone off the scale. Mega ohms, 20k. Okay, so it looks like 1 kilo ohm. 1 kilo ohm. Yeah, we've got 991 ohms. Okay, so what that probably is a bit of resistance due to the sort of carbon build-up and the grime that's on the surface of the glow plugs. It could also be sort of internally in the glow plugs. They've burnt out, but there's still a tiny bit of current flowing through the sort of remains of the heating coil or whatever's inside them. Okay, one thing's for sure, it's not 1 ohm, it's 1 kilo ohm. Okay, so all 4 have died. It happens. Interestingly, when I mentioned this on the Facebook group years ago, because these have been blown for a few years, and I mentioned it, and somebody piped up and said, "Oh, I've been a mechanic for 50 years. I've never come across a car with all 4 glow plugs blown. The chances of that, it would never happen. It would never happen. You'd be better off buying a lottery ticket." Okay. Really? Well, here's the evidence. Something's going on here. Either these all four have blown, or I've got a wiring break somewhere. Okay, so it's possible that the wire is broken or disconnected or something. But I've actually come across quite a few people where all four glow plugs have blown. It does happen. The problem is the car will still start with three or two, maybe even one glow plug. It'll still start. So you wouldn't really know about it until all four are blown and it doesn't start. Okay, so fuel filter's off and the inlet manifold is off. Those two tasks will be shown in different videos. Okay, so that will be sort of effectively part one for the fuel filter, part two for the inlet manifold, but also the refitting of those. I'm now able to actually get to the glow plugs. Okay, so they are here, somewhere behind there and there. Okay, and those four wires go through this big connector here and then into the loom and off to the fuse box and the relay, or the control module, depending on which type you've got. Okay, so what I'm going to do now is pull off these, carefully pull these kind of caps off. Carefully, I'll just have to probably just get some pliers and pull those off, and test each glow plug one by one with the meter, the resistance test, and that will tell me if they really are faulty or if there's a wiring fault, which I'm not ruling out at the moment. Okay, it's unlikely, it's more likely that they've actually blown, but I will test them. I've put some tissue into the inlet ports there. I've not bothered doing these ones here because they sort of go uphill, so it's unlikely that things are going to go up in there, but these ones are sort of sloping downwards a bit. Didn't want to drop anything into those, even dirt. Okay, so I don't want to get any nuts or bolts or anything dropped in there. That would be a disaster. But also I want to try and keep them as clean as possible. Okay, so protected those. I'm now going to pull off these plugs and measure the resistance of these glow plugs. Right, okay, so let's just put this onto continuity mode. Right, and yeah, well, let's just try with that. Okay, nothing. Let's go to a hot. Oh, hang on a minute. Well, that one's got that one actually. Maybe not. Let's go to 20 kiloohms. Okay. Come on. Nothing. Okay, that one's 3.5k, 3.5 kiloohms, and that one is 1.5 kiloohms. It's 1.5 kiloohms on that. $3.5k. Let's get a proper reading out of these. Come on, mega ohms, 20 mega ohms. Oh my god, this is absolutely nothing on that one. That's nothing at all. Totally open circuit. And that, oh, hang on, we've got 16 mega ohms on that one. Okay, so they are all blown. Whoever it was that said that never happens, it has happened. Okay, so they're all blown and they all need to be replaced. And I was really kind of hoping that actually they would all be fine and it would just be a wiring fault, but it's not. The plugs have blown. So what I'm going to do now is give them a good squirt of WD-40. And let that soak in for a bit. Because I really don't want these shearing off. A disaster. Okay, so I've got my new little torque wrench here ready. An assortment of connecting rods here, because this is a 1/4 inch, and the socket that I've got here is a 3/8, a deep 8mm socket. So I've had to kind of enlarge back up from 1/4 inch to 3/8, because I've got a reducer 3/8 to 1/4, but not 1/4 to 3/8. So I've managed to do that with this piece here. One of these funny like extender kind of, it's designed to go in a drill with a 3/8 thing there, but it works fine in this. So here we go, moment of truth. Okay, this is the point in the project that I've been dreading, and this is the the scary bit really. So these glow plugs have been screwed into this engine, sat there for 14 years through hot and cold, probably caked in soot and rust and God knows what. Okay, so if these shear off, then I've got a really big problem. Now, reading up on the internet and watching some YouTube videos, I've learnt that the shear torque on these it's about 20 Newton meters. I mean, the actual tightening torque on Bosch glow plugs is only 10 Newton meters. Some are 15. I think the NGKs may be 15 or 20, but I don't know what brand these are. You see, they were whatever Land Rover put in the factory. I don't want to go over 20 Newton meters undoing, okay, because that's for an 8mm or M8 threaded glow plug, 20 Newton meters is the sort of accepted shear torque. Okay, so what I'm going to be doing here is using the torque wrench in a sort of an undoing setting. Okay, luckily there's a little lever here, and I've set it to start with, I've set it to 15. Okay, so 15 Newton meters. And another little trick that I've learned is if you tighten it a little bit, then try and undo it, it just sort of breaks it free a bit better. So it might be a case of just clicking it over and over and over each way, one way then the other, against that torque limit. Eventually it should start to turn, but let's see how we get on here. So I need to put this in a doing up mode, right, and then get that on there nice and straight. Not even on there. Yeah, there we go. Right, and then do this up. Come on. Oh, dear. Okay, I'm sure it's moving, but this is a bit scary. I think I might, I'll tell you what, let's just set this to 10. 15 seems a bit much. Let's just set this to 10 to start with and see how we get on. 10. Okay. Oops. Okay, let's just see what happens at 10. Right, there we go, it's clicking. Okay, so I'm now going to try and undo it. We'll just see if it undoes. Oh, look at that, it's undone, I think. Oh yeah, it's turning, it's turning, it's turning. Oh, blimey, God, that wasn't very tight. It was like 10, well, less than 10. So tightened it to 10 and then it undid less than 10. That's actually coming out. Oh, blimey, I hope they're all that easy. Right, look at this, look at this, look at this. It's come out. Wow. Wow. There it is. And it's not in too bad a state, actually. I was expecting this to all be black or rusty. Let's just have a little look. So these are NGK 11 volt. Okay, so that confirms that I've got the 12 volt, 11 volt glow plug. These are NGK. Now, I could connect that across 12 volts and just see if it gets hot, but it's a high resistance. It's not going to do anything. Okay, so that's one. Right, one down. Oh, I really hope the others come out that easily. Right, okay, come on. Come on. Come on. Come on. Oh, it's coming out. Every time it kind of goes, I think it's breaking off, but it is not. It's actually undoing. Now, I think drenching these in WD-40 early on in the process has really helped. Okay, so if you can, just leave it overnight soaking in WD-40 or some other sort of penetrating oil so that it really gets down that thread. No sign of any copper grease on those threads, but yeah, right, let's see if we can get the next one out. Now, this is a little bit more difficult because of the coming underneath the pipe. I wonder if this is why they say to remove the okay, we're in there. It's really important to get lined up properly. No, it's not on there. It's not on. It's not on. Hold on a minute. It's not on. I think that's why they say to remove this pipe. Ah, there we go. Okay, so that thing there has rotated round very slightly and that's allowed the pipe to just move down a bit. Just zoom it out slightly just so you can see what I was talking about. It's this thing here is on a ring around the pipe, so if you push the pipe down it actually does go down a bit. That sort of rotates slightly. Right, let's just see if I can get this on there. Hold the pipe down. Oh. Come on. Come on, come on. It's undoing, it's undoing, it's undoing. Oh, come on. Come on. Right. It's coming out. Okay. Come on. Come on. Right. There we go. Right, oh, that one's a bit more burnt looking. That's got some sort of soot and rust and whatever on it. That's this bit's clean, same as the others, but it's this electrode is yeah, in a bit of a mess. That could mean that cylinder's running rich or something. I don't know. But that's another one out. That's 3 now. One more to go. One more to go. Oh, please, can this come out? Right. Come on. Come on. Oh, God. Every time it does that, I think it's snapped. Come on, right. It's coming loose. Hey. Oh, come on, it's coming out. Oh, God. Oh, oops. Oh, that's it. All 4. Oh, I'm so relieved. So pleased. I've been dreading this moment all year. And that's it. 4 glow plugs. All came out without snapping off. Blimey. Breathe a big sigh of relief. Okay. Good. Oh, I feel exhausted. Exhausted with relief that they've come out okay. So, goodness me, right. Well, that's good. That is good. Okay, right, I need to get this back together now. So that's the point at which destruction stops, construction starts, and start rebuilding this now. So I've got to get the new glow plugs. I'm going to put them in with a little bit of copper grease on the threads, just so that whoever removes them next can get them out just as easily as those come out. And yeah, and then it's yeah, inlet manifold, throttle body, fuel filter, connect everything up. Yeah, still quite a lot of work to do. Probably another couple of hours of work really to rebuild it all. And one thing that I wanted to do is to see if this pipe could be replaced by a nice blue silicone pipe. I've actually bought a hose, but I just don't know if it will make it round all the bends. Okay. Where's the other one? There's one missing. Right, okay. Let's get these out of the boxes. Let's just see how these compare. Yeah, exactly the same. So NGK and Bosch are, they look exactly the same. Both 11 volts. An identical fit. Same 8mm socket. Okay, so what I need is a little tiny bit of copper grease. We've got to use the torque wrench to put these back in now. Okay, so reading up on the web, it's 10 Newton meters, which is what the torque wrench is already set to put them in. It doesn't sound very much. I'm used to kind of tightening things right up, but glow plugs, nice and delicate. Go easy with this. It's just some copper grease. It's just actually for brake pads and things like that, but it's the same. It's just copper grease. So I'm going to smear it not just on the threads, but on the main shaft, not the electrode at the end, which gets red hot, but on the smooth bit as well. Right, that in there. Obviously not on the copper grease is vaguely conductive, so you don't want to get it any higher than the hex bit there, because it will bridge that insulator, which could cause a problem. Now I have seen a video on the web where Somebody actually used an angle grinder to sort of cut a groove down the thread. The idea being that next time you come to remove them, any penetrating oil you put on will find its way down a lot easier. I'm not going to do that. I just don't think it's really necessary. Right. One more. Okay, I need to tighten those up now. Right. Just getting them finger tight first. Okay, now to crank them up a bit, but not much. Right, okay, so double check. 10 Newton meters. Doing up, right. Hang on a minute, it's moved. Okay. Right. Come on. Come on. It's tiny, I'll just... Come on, please click. There we go. Right. One, two, 3 here. Get in there. 3 and now 4. Right, last one. Just got to watch it adjust the torque as you operate the torque wrench. Come on. Come on, click. Yeah, that's it. 4 new glow plugs. Thank God. Right, okay, so let's get the connectors back on. And then what I'll do is, just in case there is also a wiring fault, I'm just going to test the resistance from the relay again. And we should see 1/4 of an ohm, hopefully. Another look in here. My relay. Okay. I'm getting the meter on it. So resistance, put that there so you can see it. Just see if I've got that right. There, see that. So, okay, so we're going to go on terminal. And then engine block. Ah, there we go. There we go. 0.3. Roughly 1/4 of an ohm. Rounded up. So that's good. That proves that when the weather is cold next, and the computer instructs the relay to energise, 12 volts is sent down that wire, that all 4 glow plugs will heat up. Right, I think the next thing to do is find the new seals and the new inlet manifold.